Hello everyone. Um, this video we are going to finish the leftover we had from last class. We have been talking about the operations of radicals. We know we could only add or minus or subtract radicals if the radicals are like radicals. When we combine like radicals, we combine their coefficients. And we also covered the multiplication of radicals, actually square roots. And we didn't have enough time to cover the division of square roots, so we're going to finish this in this video. Let's start from the definition of conjugates of radical expression. Let's say we have A positive and B also positive. Then we define square root of A plus square root of B and the square root of A minus square root of B as conjugates. Okay, for example, anyone could tell me what's the conjugate of square root 2 plus square root 3? By the definition, the conjugate would be the difference of root 2 and root 3, right? And if I ask what's the conjugate for square root 5 minus square root 7, then the conjugate of this expression would be root 5 plus root 7. Is that clear? So that's the definition of conjugates. So now I'm going to multiply two radical expression. I want to see the product of root A plus root B and root A minus root B. Okay? And what technique we can apply in order to multiply the two expressions. We see two terms in the first parentheses, two terms in the second parentheses, right? So the technique we're going to apply is called FOIL, F-O-I-L. We have practiced that technique for many times. So this is how are we going to do the FOIL. F stands for first, O stands for outside, I stands for inside, L stands for last. So we're going to have first times first plus outside times outside plus inside times inside plus last times last. So I always take time to have those 8 parentheses. First, what should we put in the parentheses? The first term in the first parenthesis is root A. First term in the second parenthesis is root A. Outside. This is a plus, okay? Outside times outside. We can see root A and the negative root B, they are on the outside. Root B and root A, they are in the inside, right? So the outside term is going to be root A times the negative root B. Be careful with the sign. The two terms in the inside, on the inside is root B and root A. Last, the second, the first parenthesis is the negative root B. Yeah, let's take time to do that step. Don't rush. Root times root A. Do you remember what's the product of root A and root A? We practiced this before, right? Root 2 times root 2 equals 2. Root 3 times root 3 equals 3. Root 5 times root 5 equals 5. And so on. You see the pattern. Root something times root something is the thing. Remember that? So what is root A times root A? You would know root A times root A equals A. Root A times negative root B. Positive times negative. So we're going to have a negative here. Root A times root B is root AB. We have that formula also last class. If both A and B are positive, then root A times root B is root AB. Root A divided by root b is the square root of a over b. We have this described as the product of square roots equals the square root of the product. And this one, the quotient of square roots equals the square root of the quotient. Yeah. Okay, so let's continue here. Root b times root a equals root square root of b times a. Is square root a times b and the square root b times a the same? Supposed to be the same, okay? Because we know 2 times 3 equals 3 times 2. They are both equal to 6. And the last term, positive, negative, so negative here, root b times root b with that b. Very careful with the sign. As we mentioned earlier, square root of ab and the square root of ba, they are the same. So the two terms in the middle cancel each other. Then we end up with a minus b, okay? Here I want you to write down a formula. Square root a plus square root b times square root a minus square root b equals a minus b. The result is a subtraction is a difference. When it comes to difference, we need to be very careful with the order. A must be in front, followed by b. A must be not the other way around. Okay, this is the formula of the division of square roots. So let's look at the two examples. Example 1 of let's okay. Yeah, the requirement of this problem could be simplify the given radical expression. So the same with before, when we talk about simplify an expression, we need to know the criteria for an expression to be simplified, right? We see a radical expression not simplified if the expression has a radical in a denominator. Okay, so here, in order to simplify this radical expression, we see square root 2 on the bottom, right? We need to get rid of the square root from the denominator. So that's the purpose, that's the criteria we're gonna try to meet. You can also see this expression is a division of radicals. Numerator is 1. 1 can be seen as the square root of 1, right? Denominator is root 2. So that's a division of two radicals. So how do we do that? First thing we need to do is we need to find the conjugates of the denominator. Okay? Find the conjugate of the denominator. Did we just cover the definition of the conjugate of a radical expression? Root a plus root b has conjugate root a minus root b. But look at here, looks different, right? The denominator is just the root 2. There's only one radical. But what if you think about root 2 as root 2 plus root 0? Then the conjugate would be root 2 minus root 0. And it's still root 2, right? Yeah, you might see it already. The conjugate of root 2 is itself. The conjugate of root 2 is itself. So we are going to multiply both top and bottom. That's going to be our step 2. Multiply both top and the bottom by the conjugate that we found from step 1. Conjugate. Right? So we agree the conjugate of the denominator, the conjugate of root 2 is itself. So we are going to apply the multiplication property of a fraction. This is a fraction, right? Numerator, denominator. We're going to multiply both numerator and the denominator by the conjugate root 2. All right. So let's see what do we have. Numerator, we have 1 times root 2, that is root 2. Denominator, we have root 2 times root 2, that is 2. And we're done. Because the new expression, this expression, has no radical on the bottom, and it is equal to the original radical expression, right? So 2 steps for the division of 2 radicals also can be described as simplify a radical expression if you have a radical on the bottom. Step 1, find the conjugate of the denominator. Step 2, multiply both top and the bottom by the denominator, by the conjugate of the denominator. So this is example 1. Example 2. You can find this example from the notes. So let me see the notes. We have a few problems on the notes. By the way, the notes is already posted in Moodle. You can access to them anytime that you need. Okay. So let's see this one. 5 over root 7 plus root 3. 5 over root 7 plus root 3. So let's see, how do we divide 5 by the addition of root 7 and root 3? In other words, how do we simplify this rational expression? Well, let's apply the procedure, the 2-step procedure. Step 1, anyone could tell me the conjugate of the denominator? The denominator is root 7 plus root 3. So what's the conjugate? Yeah, by the definition, if you scroll up, you can see the definition. The conjugate is going to be root 7 minus root 3, okay? Yeah, we covered this earlier, just a moment ago. Step 2, we multiply both top and the bottom by the conjugate, which is root 7 minus root 3. Root 7 minus root 3, okay? Yeah, this property is called a multiplication property of a fraction. Suppose you have a fraction a over b. Of course, denominator b is non-zero. You could multiply both top and the bottom by a non-zero constant without changing the value of the fraction. That is called a multiplication property of fraction. I think we talked about this before, but we use it again here. All right, so numerator, if we distribute, 5 is outside the parentheses, right? 5 would be the coefficient of the parentheses. 5 times root 7, we have 5 times root 7. 5 times the negative root 3, we have a negative 5 root 3. On the bottom, root 7 plus root 3 times root 7 minus root 3. So do you have the formula that I ask you to copy down? Do you see this formula? What's the product of 2 radical expressions if they are conjugates of each other? Okay, you're going to apply that formula. If you apply that formula, you would have the denominator becomes 7 minus 3, which is 4, right? And this is good enough. Yeah, even in the numerator you don't distribute, I think that is fine. Yeah, because we have nothing to reduce here. This is going to be the final result. One more, example 3. This example also, you can also find it from our notes. We have root 5 plus root 3 all over 2 root 5 minus root 3. Yeah, this one is quite complicated, but the 2-step procedure would still apply. Let's see, how do we apply that? Yeah, this is a division of 2 radical expression. Numerator is root 5 plus root 3. Denominator is 2 root 5 minus root 3. I talked about this before. The fraction bar serves as a division symbol. This is fraction part is the numerator, this denominator. So this is a division of two radical expression. What's step one? Yeah. Think about it is a simplified form. But it doesn't change the definition of the conjugates. So what if you think about this one as the square root of 20? Square root of 20 is the same with 2 times square root. 2 times 3. Okay, with that, so C of 2 and equals x is root a. Our this okay, this is the y. You have x minus y times x plus y. By the formula, you have x squared minus y squared. Is that clear? Let me erase that. Okay, so yeah, this is a square root. Oops. So root 5 to square 2 minus root 3 to the power 2. And what is the square of 2? So we're going to apply a power of part here. Remember, power of product formula is from chapter 5 of algebra 1. Square of 2 is 4. Square of root 5, which is root 5 times root 5, that is 5. Minus root 3 times root 3, which is 3. So the denominator ends up with 4 times 20, 20 minus 3 is 17. Now let's deal with the numerator. How about this time, let's do George. Did we talk about George before? This is the left eyebrow. So we have root 5 times 2 root 5. Right eyebrow. This is root 3 times root 3. The mouth of George, which is 2 times root 3 times root 5. This kind of figure. Root 3 times root 5. And the chin of George, root 5 times root 3. So you can see that George is smiling at you here, right? Same with for you. Either way works. You can just apply whatever you feel comfortable. So left eyebrow, root 5 times 2 root 5. Root 5 times root 5 is 5. 5 times 2 is 10. Root 3 times root 3, 3. 2 times root 3 times root 5 is twice of root 15. Root 5 times root 3, 1 times root 15. Okay, so let's combine the radicals. Those two are like radicals. We have 10 plus 3 is 13. 13 plus 3 times root 15. Is root 15 already simplified? Yes, 15 can be factored as 3 times 5. So it's already simplified. Okay, so that is the division of radicals. We didn't finish last time. This is section 9.4. Section 9.4.